Very good evening, students of class 9. Today I will be teaching you the remaining portion of Unit 1. In the previous unit, in my previous video, I taught you the different technical terms, including rest, motion, then your distance, displacement, rest and motion as relative terms, then motion in one dimension, what is motion in one dimension all about. Then I discussed about, as I told you, about distance and displacement. What is the difference between distance and displacement? This thing I have discussed in the first part of my video, and today I will be teaching you the remaining technical terms in Unit 1 of Class 9 Physics. So please watch out. Today I will be starting with the first one, that is speed. What is speed all about? As far as the definition of speed is concerned, it is nothing but the rate of change of motion with time, or rate of change of distance with time. Means in many other books you will find that distance covered by a body in unit time interval. Unit time interval means 1 second, 1 minute or 1 hour. Means whatever is the distance traveled by a body in unit time, that is known as speed of a body. So speed is nothing but distance covered by a body in unit time interval. As far as the nature of speed is concerned, it is a scalar quantity, it doesn't have any direction. So I am writing over here, as far as speed is concerned, it is a scalar quantity. The unit of speed, its SI unit is meter per second. Meter per second, m/s. You can write in this manner, or you can write ms to the power minus 1. CGS unit is centimeter per second, cm/s or cms to the power minus 1. Okay. Now move on to velocity. Velocity also bears the same concept like speed. Velocity is rate of change of not distance with time, but it is displacement with time. In other words, you can tell that whenever a body covers a certain distance in a specified direction, means here direction will be involved. Whenever a body covers a certain distance in a specified direction in a certain interval of time, that interval of time should be unit time interval, then that is known as velocity. As far as the formula of velocity is concerned, it is equal to displacement by time. I am writing the formula of both speed and velocity here. As far as speed is concerned, the formula for speed is distance divided by time. As far as the formula of velocity is concerned, this is for speed. For velocity, the formula is velocity is equal to displacement by time. Remember, velocity, in case of velocity, direction is involved. So velocity is not a scalar quantity. As I explained in the first video, the difference between scalar quantities and vector quantities, those physical quantities having only magnitude are known as scalar quantities and no direction. As far as vector quantities are concerned, they are having only magnitude. As far as vector quantities are concerned, they are having magnitude as well as direction. So since velocity is having magnitude as well as direction, so velocity, its nature will be, it is a vector quantity. The unit of velocity is same as speed. Same as speed. Now come to uniform and variable speed. Now first I will start with uniform speed. What is uniform speed all about? Listen to the definition carefully. When a body covers, I repeat, when a body covers equal distance in equal intervals of time, then we say that the body is moving with What is the key word? A body covers equal distance in equal intervals of time. Example. As we all know that our school is in Dropgate, Urundutinagar, Agartala, Tripura. Now, a student from class 9 section A or section B is told to go to Dropgate. From Dropgate he will go to Bartala. Now suppose from his or her class, the distance from his or her class 9A, 9B or 9C, from there to Dropgate is 5 km. From Dropgate to Bartala is again 5 km. If that person has covered that 5 km, the first 5 km in 1 hour, the next 5 km in 1 hour, it means he or she has covered equal distance. First 5 km 1 hour, next 5 km 1 hour, means he or she has covered equal distance at equal time. Then I will tell that that person is moving with uniform speed. But if that person doesn't cover the same distance in equal intervals of time, means if a body covers unequal distance in equal intervals of time, then he or she is not moving with uniform velocity, he or she is moving with variable velocity. Okay, he or she is moving with variable speed. He or she is not moving with uniform speed, he or she is moving with variable speed. Is that clear? The same example I am reciting once again. That student went from his or her class to Dropgate 5 km. Okay, but in the first 1 hour he or she couldn't cover 5 km. Okay, in first 1 hour he or she has covered 3 or 2 km. In the next 1 hour he or she has covered 5 km. Then will you say that he or she is covering equal distance in equal time? Maybe in the second half she is covering or he is covering not 5 km, 3 km. Then in this scenario, the distance covered in both half, school to Dropgate, Dropgate to Bartala, which was 5 km, 5 km. Here in this context it is not same, it is different. But the time is 1 hour, 1 hour. So we are in a position to tell that that individual is not covering equal distance. He is covering unequal distance in equal intervals of time, 1 hour, 1 hour. Then that individual is moving with variable speed. Clear? Now, the next one is uniform and variable velocity. Uniform velocity and variable velocity. This one also bears the same concept like uniform speed and variable speed. The only thing is, in the definition I will mention about direction. Uniform velocity, I repeat the definition, when a body, in uniform speed, when a body covers equal distance in equal intervals of time. Here I will tell uniform velocity, when a body covers equal distance in a specified direction in equal intervals of time. Okay, the example also bears the same. Then we say that the body is moving with uniform velocity. Variable velocity, when a body covers unequal distance in a specified direction. I repeat, when a body covers unequal distance in a specified direction in equal intervals of time, then the body is moving with variable velocity. For example, a dog chasing a cat, will he be moving with uniform velocity? Not at all. He will be moving with variable velocity. Sometimes the velocity will be less, sometimes more. Now come to instantaneous speed and instantaneous velocity. What is instantaneous speed? When the speed of a body changes at regular intervals of time, it changes, okay, and you want to calculate all of a sudden the speed, then how will you find? Means instantly. The word instantly means all of a sudden you wanted to find the speed. Then the speed will be found out by the distance travelled divided by the shortest time interval. Means in how much short time a certain distance has been covered will be calculated, and then you will find the instantaneous speed. Instantaneous speed, why we this particular technical term arised because sometimes what happens in our daily life when we ride a bike, the speed of the body suddenly changes. The speed of the bike suddenly changes. It increases suddenly, it decreases suddenly. Okay. Now, if the road is empty, it will increase. If it is too huge, if there is too much traffic, then we have to decrease the speed. So when there is a sudden change in speed, okay, the instantaneous speed is calculated, or it is basically the ratio of the total distance traveled by the short interval of time taken. Instantaneous velocity also, it is same, only here direction will be involved. Okay, the distance traveled, instantaneous velocity is equal to distance traveled in a specified direction divided by time interval. Time interval is the short time interval within that span of time. Means when you thought of noticing the speed. Now, a device generally records the instantaneous speed and velocity, and that is nothing but speedometer. In every vehicle, you will find a speedometer. There is a needle which will tell you. All of a sudden, you thought that what is the speed with which I am riding the bike. The speedometer instantly will tell you the speed. How it tells? It calculates the total distance traveled in a short interval of time. Clear? Now come to the next topic, the last topic, acceleration and retardation. Acceleration and retardation. Now what is acceleration all about? Suppose you are having a car. Your father wants to go to the market. You told that you will be accompanying your father. Now the moment your father switched on the car, what happened? He pressed the accelerator. Obviously, when your father will try to drive the car, he will not press the brake, because in case he presses the brake, then the car will not move. He will press the accelerator. Now when he presses the accelerator, one thing happens. The velocity of the body increases with time. It doesn't decrease with time. So whenever the velocity of a body increases with time, I repeat, whenever the velocity of a body increases with time, we say that the body is having acceleration. Okay? But while writing the definition, how do you write? Acceleration is nothing but rate of change of velocity with time. Formula, when I tell rate, means velocity divided by time. So acceleration is nothing but rate of change of velocity with time. Now what will be the unit of acceleration? As far as the unit of acceleration is concerned, its unit is meter per second square, m slash s square, or ms to the power minus 2. Clear? Now this is accompanied with another definition, that is retardation. In case of retardation, suppose your father now wants to stop the car. So he will not press the accelerator, he will be pressing the brake. When he presses the brake, the velocity of the body is not going to increase with time. It is rather going to decrease with time. So whenever the velocity of a body decreases with time, we tell that the body is having retardation. Okay? So in case of retardation also the formula will be same, velocity divided by time. But in case of acceleration, the velocity is positive here. Okay? So retardation is basically nothing but negative acceleration. It is also known as deacceleration. The unit of retardation is same as acceleration. The unit of retardation is same as acceleration. Clear? Retardation is also known as deacceleration or negative acceleration. Clear? So that's all in unit 1 as far as the technical terms are concerned. So unit 1 is finally over. In my next video, I'll come up with the second unit. So in the second unit, what I'll be teaching you, I'll be teaching you about the graphs. Okay? Means as a body moves in straight line, or when a body exhibits one-dimensional motion, then that one-dimensional motion can be studied with the help of 3 different types of graphs, and those 3 different types of graphs I will be telling you in the next unit. So before I end this video, I would like to urge you once again, please stay home, stay safe and follow the guidelines as issued by ICMR and the government. Thank you.